Yes.
Okay, awesome. Let's start. So, working with data in Python for beginners. Let's just get this nice and full screen. So, my name is Jean-Pierre Vogt. You can call me JP. I am a data analyst from South Africa, aspiring data scientist. And you can follow me on Twitter, contact me on email at I'm generally very good at responding back to emails. It normally does. I normally respond within the next 3 months. Or you can go to my GitHub repository where you'll find everything that I'm showing you today in the same notebook format, and also a lot of other Python little snippets that I'm saving up and collating to help me save my time a little bit. So let's start. Why Python? And most of us, or me coming from a SQL background, working with BI a lot, SQL development, and moving into a data analyst role later in life. And so I'm pretty much focused on the SQL environment, everything Microsoft SQL related. And a while ago, I started looking and I saw this Python is the latest new buzzword, data science, all these fun little, buzzwords. And I started looking, and what my dad always taught me when I was little was you have to use the right tool for the right job. And I quickly found out that there's a lot of things that I was doing in SQL that SQL was not really designed for, or it can do it, but it wasn't built for this purpose. So to give you an example, a couple of weeks ago, I was given the task to just QA a couple of files that was generated in our business. And sure, how difficult is it looking at opening a few files and checking if the data in there is correct? To my surprise, they gave me just over 1,000 files of 4 gigs per zip archive. When I unzipped the first file, it was 180 gigs. Now imagine I now have to unzip 1,000 files, which at the end will be 180 gigs. I do not have the space or the time to work with this. So spend a day looking through building a quick Python script, and I found I can read the data directly out of the zip without ever unzipping it and only pulling out what I need. And 2-3 hours later, went through all the files, have all the information I required, and imported it into SQL and did my analysis there. So, right tool for the right job. So, let's get started. How to get started with Python, because all of us wants to, we need a starting point. And you can go to the python.org website and you can download Python directly. If you're running Mac or Linux, you will have it pre-installed on your system, and you can just start installing all the libraries which you require, which we'll get to a little bit later. But my recommendation is to go to www.anaconda.com and download Anaconda distribution. Now, Anaconda is a already packaged distribution and package manager of Python. What that means, it comes pre-installed with a couple of or the most important libraries which you require to work with data in Python and doing machine learning, data science, data engineering. Most of the libraries just comes pre-installed. One thing to note that you'll see, it doesn't matter where you go in the Python environment, you'll always see the reference to Python 2.7 and Python 3.7 or 3.8, which would be released, I think, next week. And that is essentially 2 completely different languages. It is at the core, it was redeveloped and it was improved quite a lot in Python 3.7, but Python 2.7 still are supported for corporate environments. So I think Michael, can you just put up a poll to ask how many of our attendees have worked with SQL, with Python before? I'll continue. I think I can continue while everyone just give me a quick yes or no answer. What I would also recommend is if you are working on your work machine or you're not if you don't want to install any applications on your machine, you can go to a website called Kaggle. So on Kaggle, you get hundreds of data sets. And this is like a very nice environment where you can learn. And with all these data sets, you can go in. So let me show you the data set we'll be working on today. You can have a look at, I'm going to show you the PGA Tour golf data. And it gives you a quick description of the data set, what data is available, what columns, a quick view of the data, and just a few statistics of the data. If you are happy, you can click on New Notebook, and it opens a Python notebook, which we'll get to now. And you can immediately start coding in Python in your browser and start working with everything that I'll be showing you today. So just to go back to my local instance, let's go back in. You'll see that there's also a couple of different IDEs. So what is IDE? So I'm going to try and relate this talk as close as possible to home. When I say close as possible to home, I'm going to try and make connections to the our SQL lives, and see how closely I can relate that. And if you think about SQL, a big part of my job is to teach people how to code in SQL and how to work with SQL coming from a completely non-technical background. And a lot of people's misperception is that SSMS, SQL Server Management Studio, is SQL. If you close it, you close SQL. Now, all of us know that not all of us, but most of us know that's not true. SQL is the engine, the core engine, and Management Studio is just the interface you work with when you're working with SQL. So if you have that picture in your mind, there's a very popular Python IDE interface that you can work with is PyCharm. You can use Spider, which comes pre-installed with Anacondas, VS Code, Visual Studio Code, which is a very powerful lightweight IDE from Microsoft, completely open source with hundreds and hundreds of extensions. You get Python extensions, you get one of my favorite extensions in VS Code is a curly or bracket highlighter. So it just shows you the colors of brackets if you work with nested brackets a lot. And Jupyter notebooks. So Jupyter is what I'm going to, this entire presentation is built in. Now, to give you an idea, let's get started before I show you the awesome part that's completely life-changing for me doing presentations. So step one, in Python, you have this concept of installing libraries or importing your libraries. Now, if I'm trying to relate this back to our SQL world, is you will have SQL always have the ability to do, let's say, checking different DMVs. But if you install the first responder kit from Brent Ozar, you get a couple of like SP Blitz index, those kinds of stored procedures. And if they executed, that is a combination of different instruction sets helping SQL to accomplish what you wanted to accomplish a lot quicker. Now that is the exact same concept with importing libraries. But Python has the ability to work with all of these libraries, but it does not, you don't want to code it up all the time. You just want to import it and use what has already been done. And part of this is most or almost all of the libraries in Python is completely open source. So you can go through the code, you can read up and see exactly what every library you are using or is doing. It just helps with security, and I just trust something more if I can see what its purpose is. Then let's see. A lot of let's go back. Sorry. Let me show you what libraries I'm going to import. So first off, I'm importing a library called NumPy. NumPy is a vector library. It is a way of working with 2 to 3 dimensional arrays. And the reason I import this is, the main reason for this is I use pandas. And pandas is built on top of NumPy. it is a way, it makes it or brings data a lot closer to home for especially the SQL for guys like myself. And then I've imported one or two plotting libraries just to make pretty graphs that I'll show you at the end of this slide deck. So first off, let's start off. In pandas, we have a data frame. And the data frame is quite a very simple object. In Python, it's a two-dimensional size mutable, potentially heterogeneous tabular data structure. I'm sure everyone understands that wording to the letter, but for me, I have no clue what that means. In essence, it goes back to a pandas data frame is a table. It's a normal table in SQL. You have rows, you have columns, and you have data in it. Each column has data types, and I can filter and slice and dice that data table any way I want to. This is the point where I want to ask, does everyone understand? Everyone nods their heads. So I'm hoping everyone nods their heads. Yes, I understand. If not, please feel free to ask the questions. So let's start off by importing data. So first off is I'm going to take my data or create a variable, and Python is a loosely typed language, if I have the thought correct, where I can just define a variable and I can assign a data type to it, whatever I want, and can add any object into that variable. So in SQL, we would have done this declare at date and tell this is a date time variable, just to declare the variable. In Python, you don't have to do that. You can just type dates and equals to my function. All I'm doing here is create a date range that starts at 1st of Jan for 6 periods and goes for the frequency goes in days. Next step is I'm creating a data frame. So I can call this my table, whatever I want to, and I can assign the pandas data frame, and I'm bringing in just a random number, 6 rows, 4 columns. I use my dates as an index, and my column should be A, B, C, D. And let's just afterwards display my table, and you'll see they quickly generated a table with this. Now, I hope everyone just saw what we just did, which makes Jupyter Notebooks one of my favorite presenting tools. As you can see, I was in my presentation, I went and I changed code and I executed code inside of a presentation. Now, this is sort of get shipped with Jupyter Notebooks. It is just an additional library that you need to install, which is called Rise. So you can, I'll show you at the end quickly how to install Rise library into Jupyter Notebooks, and then you have the ability to change your Jupyter Notebook, which in my worldview is I see a Jupyter Notebook as an extremely powerful Word document, because I can document my code while writing my code and executing my code in one document. If you've ever worked with Azure Data Studio, they have just released, I think it's in this month's release or it's still in preview release, notebooks for SQL. So you can do a similar what I'm doing for Python in SQL now using Azure Data Studio. Also, if you run on a Apache Spark environment, you can run multiple different languages inside of your notebook. You can run Java, R, Python, and SQL, Scala. I think there's one more, I always forget it, but you get the gist of it. The very, very nice thing about Python is, like I mentioned earlier, is everything's open source. And you can go and find the very good documentation on everything that I've just showed you here, or you can inside of your code query the documentation of a function that you want to use. But first off, what I want to do here is I just got this piece of code quickly on the internet to loop through a directory. This is my working directory, and print all the CSVs in my directory. And you can see I've downloaded the PGA data historical.csv from the Kaggle website, and I can also in Jupyter use Unix commands, or a base of Unix commands. So I can use the %ls or %ls, and that will return the directory structure and all the files inside of my directory that I'm working at the moment. So let's start with a little bit more of a real world example. So first off is I want to insert or read data from that CSV. But just to show you a little bit of how powerful this pandas library is, I've went and I've zipped my CSV file. I created the zip file of it, and I'm telling it, pandas, please read this CSV in its zip form. So everything here is commented out. That's not required, but you can specify your separated decimal. There's a lot of different extra parameters that you can give it, and insert this into a data frame. So this is essentially in SQL that read open row set, so read your CSV and insert it into this table, the called data frame. I was calling my table data frame to force myself to use the correct terminology in Python. And if I run this, you'll see there's a little star there on the left-hand side. That means this is running. And as soon as the number appears, it shows you this is the sixth query that I've executed in my session at the moment. And I can now go and have a look at my data in my data frame. But this is, I'm just calling it. So I do a select star from my data, and it returns this. But I want to know, what can I do with this table? So at any given time with any object, I can invoke the help command. So what the help command does, it returns the documentation of a data frame for me, which you can see I have, it just goes on and on. So it explains it in very detail with examples on how to use it, how to get data in and out, and all the methods and functions you can invoke on a data frame. But because I want to show you guys this and guide you a little bit to save yourself some time, let's start looking at different ways of presenting our data. So if you work in any other IDE than Jupyter Notebooks, just calling, like I did earlier, data frame, it will not return anything. You have to invoke the print command to return whatever you are working with, the object, to the screen. So I'm calling, so this way you can see I'm printing my data frame. I'm asking it .head. This is the Unix command, which is also part of pandas that you can use to return the first two records in my data frame. So this is essentially a select top two from my table. But then, let's just get there. And because I'm in Jupyter Notebooks, I do not have to invoke the print command. And when I run it without the print command, it actually returns it quite nicely in a table format, which is much more readable than the print format at the top. So let's go into a little bit more functions and looking at our data. The first function I want to show you is shape. So what shape does, it just returns the number of records and the number of columns in my data set. You can see this data set has 2.7 million records and 5 columns in it. Quite simple. And we've been through the Unix commands of head, and there's also a tail where you can say, in the instance of head, I can tell it head n, so head 2, return the first 2 records. I can do head 7, and it will return the first 7 records for me in my data frame. Doing that, I can also have the tail function, where I can tell it the last 3, last 9 records, just return the last ones based on the index. As you can see, it is quite fast. It returns my data very, very quickly, and you saw there's 2.7 million records in my data frame. And wondering why it's so instant? And that is because Python and a data frame has this concept of it pulls everything into memory. Now, because it pulls everything into memory, there's something that you need to really watch out for when you're working with data, is the fact that it pulls everything into memory. because imagine working with a 100 gig file, trying to importing that into a data frame. Bam, 100 gigs of your server or memory is gone. I'm fortunate enough that the organization I work for has given me quite powerful servers to play on, so that's not the end of the world. But if you're trying to do it on your laptop at home, it will just throw you an error to say it cannot do that. Well, in that instance, I would recommend just using the data that you require or sampling your data to smaller chunks. So now I've showed you essentially the select top star from table equivalent in SQL and how to do that in Python. But as we all know, it's not always a great idea to do a select star, and you want to only query the columns that you require. So what you can do in Python is you have the square bracket notation, where directly after your table name you can specify a square bracket and then the column name, and when you run this, it returns only the column name of player names, player name. And just for simplicity of size on my screen, I've limited it to the first 5. Now to take note, this returns a object called a series object, no longer a data frame. I showed you earlier how, because I can call my variables and my objects directly in Python to screen, data frame gets returned into a table or a pivot sort of format, where if I return with the square brackets, I get a series. But also not lost, if you want to return multiple columns, you can't do it just like this. You have to return to the double square bracket notation. Now what this does, it does return a data frame object, and I can query multiple columns. I don't have to query multiple ones, so I can show you just query a player name, and it returns this in a table format, where if with the single notation, it returns it in a series format. And again, you also have the dot notation. So this works. So this is very nice and simple to read. When you're just working with one column or just want to alter and change one column in your data set, you can call your table, your data frame, dot the column that you want to work with, and again, just filtering it to the first 2. One thing to look out for at this with the dot notation is I cannot call player name because it has a space in. Python disregards that column completely for the dot notation until you go and fix it up later. So now I've showed you how to do select star and how to select specific columns, but let's look a little bit at more in depth into the metadata of our table. So for my data frame, I have a function called dtypes. When I invoke the dtypes function, it returns all my columns and of type what object that the columns are in my data set. You can see a player name is of type object, and in the SQL world, that is your varchar in varchar. That's a text field. Season, it decided it would be an integer because it is what CCYYMM format, and it didn't pick it up as a string, so I decided I can do addition and multiplication with my season. Statistic variable of value has all been defined as object. So moving on, so now we know what our data look like. Let's look at our index. In my instance, I did not specify an index on my data frame. I allowed pandas to decide the index for me. And what it does then is it just creates like in SQL, a primary key with an identity 11, and it starts with, essentially actually starts at 0 and runs all the way to the last record. Now everything in Python is 0 based, so every record starts at 0, every character starts at 0, not at 1. And you also have a dot columns function, and it just returns all the columns for you if you want to do some loops or iterations through specific columns. Then you also have the dot values function that returns some of the values, but I'm not going to return that because it returns all the values in your data frame without the column headers. So now that we know the metadata, we've looked at the metadata, we've done simple selecting of our data. Let's see how we can learn a little bit more about data. So first off, there's the dot describe function, and what this will do is take any numeric value and calculate basic statistical values on it. So unfortunately, I only have season, so that doesn't look very nice, but it does account. I mean, my standard deviation minimum, 25th percentile, 50% percentile, 75 percentile, and max percentile. Also, there's a .t function that transposes your entire data set. Honestly, I have not exactly sure what the real world use case for this would be, but it's extremely awesome that it can transpose 2.7 million records into columns so quickly. So now I'm going to move on to, and what I've just showed you is by no means the ultimate level of data analysis that you can do in Python. Once you go into this rabbit hole, it just gets deeper and deeper, and you just learn more and more of data manipulations. So now I want to show you a little bit of the DDL modifications. And nowhere, don't go and Google Python DDL modifications or Panda DDL modifications. This is a term that I'm just trying to explain this process a little bit simpler. How to change the data definition language from how we would do in SQL into Python. So first off, I showed you the columns earlier, and when I showed you all the columns in my data frame, there's a couple of column headers that I'm not very happy with. So to go and change this, I'm calling my data frame dot rename, and I'm telling it rename my columns value. So this with curly braces is called a dictionary. So look for value and replace it with distance and return the first 3 records. Now this should give you a hint that I've renamed my column value to distance, but this is returning a data frame. Nowhere in this have I told pandas or Python to persist my change. It is just essentially what I've done now is I've written a query where I say select name as first name from my table. I haven't gone and altered my table, the column name to first name. So what you want to do is, you can see if I call my data frame again later on, it's reverted back to value, no longer distance. So what you want to do to persist it is add the parameter in place true. That tells pandas do not return the data frame. Actually, do the change to this data frame. You can also, if you're not comfortable with that notation, you can also assign a new variable with the exact same name as this data frame that we've defined up at the top. So that's a very nice functionality of Python, so you can quickly reuse variables over and over again and replace it. So what I'm doing now is essentially select name as first name into my table from my table. I think this is awesome. So let's change data types. I showed you earlier that there's my distance. I've now renamed my last column to distance, and it's of type object. And because we're working with, I think it's called yards in the PGA, I want to change this to a data type that I can do aggregations and with. What I'm doing here is I'm quickly creating a new data frame called distance. I'm pulling from my current table, and I'm just writing a quick query where variable equals my driving distance. So in this data frame, look for my column called variable, where it is equal to driving distance. So in here, there's a nice quick example of two functions or functionality or operators in Python that you need to be aware of. The first is the assignment operator. One equal sign is an assignment operator. What that means is I'm taking everything on the right and making it equal to what's on your left-hand side. Where you'll see a comparison operator is a double equals. So this will take a variable is equal to this. It's not saying take everything on the right and assign it to everything on the left. It is evaluating if this will return true or false. So after now creating this data frame, just looking at my types, I know for the fact distance will now only have the distance values in there. If I have a quick look at my distance data frame, you can see my distances here is 315.5 yards, 309.8 yards, and going on. So, but it's still of type object. So what I can do now is I can call my data frame, but I'm calling only a subset of my data frame. I'm only calling the distance column. And I'm telling it with the distance column, apply the function pandas to numeric to this distance column. And once you've done this, replace everything on the right-hand side with my data frame distance column. So I'm replacing this column with my new numeric distance column. And if I call the data types, the dtypes function now, you'll see that my distance is now of type float 64, it was of type object previously. Now this means I can now just, let's see, so after, I forgot to change my column name. It's still value. That's why you don't code live. Okay, so it's of type flat. So now I can go and tell it to do the dot describe on my distance. And you can see now on value, it gives me a count, my mean, standard deviation, minimum, and maximum of my distance of value. Now, if we want to rename multiple columns, because previously I showed you how to rename one, you can create a dictionary of all the column names that you want to replace. And I'm just assigning this dictionary to a variable called column names. And then I am replacing it, say, my data frame distance. I'm telling it rename my columns using the dictionary I've created up there, and do that in place, and then show me the first 5 records. If you don't specify a number in the head or tail function, it defaults to 5. And you can see I've renamed player name with a space, or player name without a space, and season to season underscore YY, just to understand what I'm looking at there. And again, remember to put your in place or your assignment operator to the data frame that you wanted to go. Then how to drop a column. So that is as simple as taking your data frame or your table, if you want to call it that, and saying dot drop and giving it a column name. Now here's a little gotcha, because I'm doing the in place equals true, which we should be familiar with by now. But I'm also telling it axis equals 1. So I want to know, why am I specifying an axis? So on pandas, you have your axis 0, which is your y-axis, and your axis 1, which is, so your axis 0 is your y, axis 1 is your x-axis. And so I need to tell it, go and look for a column. This is telling it, go and look for a column called statistic. If I set this to 0, it's going to look for a row called statistic based on the index, and it won't find that. Otherwise, it's as simple as telling it to drop that column. So how to sort our data. If you want to sort your data, you can have a function called sort index, on axis 1, and it will sort your data for you on that, or you can sort by column name. So all we want to do is take my table, sort it by values, and just say by player name, and you'll see now my data frame is no longer ordered by the index, but it's ordered by player name. So let's do a little bit of data slicing. If you remember earlier, I said if you do the dot notation on your data frame, you get returned back a series. And when you're working with series, there's a couple of functions you have to your disposal. And in this instance, I have the dot unique function. What this does is I want to see in my table, bring back all the seasons and return a list of unique seasons. So I can see I have data from 2010 all the way up to 2018 in my data set. I can do the exact same with the single square notation as I showed you earlier, because this returns a series as well. Just to show you, if I were to return the data frame object, the double square brackets, I will get an error just to say data frame object has no attribute unique. But if I return the series object, it works as per the above. Let's start slicing our data a little bit. We can use the same principle as what you would have done with arrays and a couple of other programming and statistical languages. So tell my table to start at record 6, at index number 6, and go to all the way up to 8, but exclusive. So everything in Python is it starts at 0 or starts at whatever you want to tell it here, but it ends at the number -1. It's exclusive of 8. It will not reach 8. You'll see there's 6, 7, then 8. So if I tell it to go to 10, it goes to 6, 7, 8, 9. It just stops just before that. Now, one of my favorite parts is that you can use negatives here. What I'm telling this is start at the 7th last record in my data set. And then, without specifying where to stop, it assumes it should stop at the end. So this is returning the last 7 records in my data set. I know we can do this with the tail function as well, but if you want to go to certain elements and slicing and dicing your data to create your own windows, you can do that. Now, the more recommended way of slicing and dicing your data is with functions with the lock and ilock functions. And with the lock versus the ilock functions, you have the difference of either locating a data set by a column or by an index. So what I mean by lock is, so I'm locating my rows, so I'm saying bring back all the rows, comma, only for these columns. So I'm telling it only bring the season and player with all my rows. I'm just stopping with head there. And then I can also tell it to just bring back one record, bring back index number 9, and just show me the season and the player on record number 9. Where if I use ilock, you tell it to from row to the to row, exactly like lock would have been, comma, from column to column. But this is index based, no longer name based. Oh, sorry, I got confused. This is index based, yes, and not name based. So I'm telling it my table dot ilock, start at record at the beginning, end at the last record, but start at column number 1, not at column 0, and bring me back all the rest of the columns. So essentially what I've done here is I've returned a data frame where I've excluded the first column from my data frame. Now this is extremely useful when you are trying to manipulate your data and build your data up for a machine learning data frame, because generally, or especially in my case, my first column is always my unique identifier or my ID number, those kinds of things, which is not very useful when building machine learning models. So how do we filter data? I showed you earlier that a double equals is a comparison operation. So I'm telling it for my data frame in player name, return, search all for all the records that is equal to any else. But as you can see what it's doing here, it's returning only false, or there's also a couple of true values in there. My data set's just quite big. It's not actually filtering the data frame for me. So what you want to do is just encapsulate the data frame up there with another data frame, with your data frame. To say, return my data frame where the operation inside is true. So this is true. If I run this now again, it normally returns your data frame for you where only any else. But what I've done here is I've asked it to also just assign this to a new data frame for me that I can query going forward. You can also use the isIn function. You don't have to use that. There equals the comparison operator. You can say where my variable is in this, comma this. You can go on for as many as you would like. You can, as you can see here, I've just done the exact same again. So I'm building a data frame of for where everyone who played in the season for 2010 and 2011 of the PGA season, and then just returning a unique list of players that played in those season. So to bring this to a little bit more closer to what I can comprehend and I understand well, is the where clause in T-SQL. What I can do here is I can tell it, take my table and query it. When I query it, take my variable equals my value. And in this instance, I wanted and distance must be greater than 315 yards. Then return me a list, a data frame, that consists of only all the players that have an average driving distance of more than 315 yards. And then if I do that, I can do the exact same operation and specify an and. Instead of having two queries, I can have one query with an and in there. Now, let's have a look at how to manipulate our data. First off, so if we want to look at, I know for a fact at record 192, Robert, I don't want to butcher his surname, was reported for 2010 to have an average driving distance of 315 yards. Now, we were contacted by management and they told us that was captured wrong. Please fix that. The correct value should be 215. So to do an update on the record, I can just tell it, locate record 192 as I did there, but locate the distance column and replace that value with 215.8 yards. So if I go on and I do that again afterwards, you can see we've now updated this average driving distance from 315 to 215.8 yards. That's quite easy, isn't it? Yes? Okay. So how to add a new column onto our data set. It is as simple as calling your data frame and referencing a column that does not exist and assigning it to whatever value you wanted. I'm just assigning a random value between 5 and 120 for the length of my players, and I call that my draw column. That is just created a new calculated column on my data frame in an instant. Now, how to do aggregations. First off, when you're doing aggregations, please remember that you need to have your data set and your columns in the correct data types. So what I'm doing here is I'm just telling it my table.group by player name and give me the max distance. There's very nice documentation online. This can get quite hefty. And there's different ways of doing this, but the documentation, Python documentation, as I've mentioned earlier, is really, really brilliant. It's well put together. So now it's time to jump up and down, stretch your arms, just to get a little bit of blood back in the body. So what I want to show you, this entire notebook is available on my GitHub page, as I showed in the beginning, and you can go and work along with your on your own pace through the entire notebook. What I have here is what I want to show you quickly. Just give it a second to load. Is, if you remember the beginning, I've imported two libraries that I said is to plot data and to make your data look a little bit better and more presentable. Because what's the point of using Jupyter Notebooks with this powerful presentation mode that I've showed you without having the ability to make pretty graphs? So to create a histogram of our data, so that driving distance pivot that was created in the exercise that you can go through in your own time, I'm telling it for my driving distance column, create me a graph of type histogram, and it creates a quick histogram of your data. Now, I was quite shocked with, it's not, I know a normal distribution should look like this, but working in my industry, I do not see normal distributions that often. This was quite a nice little graph to show. There's also, if you want a quick line chart, so what I've done here is I'm just creating a quick new data frame called Rory. So I'm just filtering on the data from Rory McIlroy. That is average driving distance, and I'm creating a new data set. Then I'm setting a parameter of how big my chart should be, just so that you can see it nice and wide. And lastly, I'm calling my driving distance and my season, and I'm plotting that on a line. I can give it a title, and I'm telling it what my x-axis should be. And here you can see the nice incline of this average driving distance from 2010 to 2012. 2013 something happened, and then back up 2014, and it started to go up again. And then if you want to do a little bit of more data analysis and understanding your data, earlier I did show you the .describe function, which I did call here, and you can see the .describe function for the 4 different metrics in this data frame. But I can also create a box plot quite quickly by just running a quick loop through my data set and returning the max, the min, the 25th percentile, 75th percentile, and the average of all of these metrics. And this is very nice to have a quick overview of your data and understanding how or what data you are working with. So now let's remember we are in Python, and this is not SQL. This is environment optimized for row-based or row-based operations, not data sets or set-based operations. And to just go back to the fact is, remember the right tool for the right job. Do not try and replace your day job, do everything with Python. Python is very nice for certain functions, especially when you do string manipulation on your data. Python just do those kinds of functions a lot quicker than SQL does it in most instances. So you can create a quick for loop for yourself, and I'm just going to show you a quick one here. Is I'm just trying to create a range from 0 to stop at 5 and print the number every time. I can change this to whatever I want, and it will go on like this. So why did I show you that? Because you can iterate row by row through your data frame as well. I can tell it my player's data frame, just turn that into an iterable object, and then print my distance and my variable for every record that I've iterated through. So luckily this data frame only has these few records, otherwise my entire screen would have been filled with data right now. So now we've come to we've done, pulled our data into Python, we've manipulated it, we've ran our functions, we've built our charts, everything is ready to go. And now what now? So now we need to get this data back into the environment where we want to use it in a production environment. So pandas have this very nice function .toCSV. So you just call the toCSV function and you give it a name. And it will take this data frame and it will export it to a CSV in your working directory. And it's quite fast. You can also do a toSQL. But to do the toSQL, you just first have to import a couple more libraries, the PyODBC and SQL Alchemy, and then you just create your engine. So this is essentially just your connection string to some server, my database, and then when you call your data frame to SQL, give it a table name, and you're just telling my connection is this engine that I've created there. Now, a quick word of caution. I prefer, when I'm working with large data sets, to export it to CSV and use SQL tools like BTS, BCP, SSIS to get the data back into SQL, because all those tools work with bulk inserts a lot better than what I could manage Python to do. And because using this method, it does it row by row, so trying to insert 1 billion records using this method does take some time. So, thank you for attending my talk, and if there's any questions, please feel free to ask them now.
Great. All right. So we've got one question so far from Shiroha, and they wanted to know is it possible to do like a SQL join between tables in Python?
Yes. It's actually very, very simple when you want to do a join. It is if you were to have a data frame A, let's say my data frame A, I just tell it to join to my data frame B. And this is now assuming that my indexes of the two tables are based off of the same information. Otherwise, you can just quickly set my index to my ID number, and it will join it then on ID number.
Great. Okay, thanks. We don't have any more questions at the moment, but it is almost the top of the hour. So I'd like to say thank you to JP. I'm sure he's gotten us all started on a brand new adventure. When you disconnect or when we close the session, you'll be asked to fill in just a session evaluation that goes to helping both us as well as the speaker improve. So please take a bit of time and fill that in. And again, we'll be having another talk next week. So we have Julie, who's part of the Microsoft product group, and she's going to be speaking about strategies in your BI solution. And then the week after that, we actually have Christian Wade, who is a senior program manager for the Power BI team, who's going to be speaking about sort of upcoming enhancements within the Power BI engine. So again, thank you, JP. Thanks so much, and we will have this video posted out tomorrow. All right, thanks everyone. Bye.
Thank you.